Hello, today we are going to look at proportional relationships in a graph. So graphing here is a comparison of two values. We have our x value, in this problem here, the number of people, and our y value, in this case, the cost in our dollars. Now a proportional relationship, as we know, is any type of relationship that forms a constant ratio between these two values. Okay, it has to be constant. What you probably remember is dividing them and making sure they're all equal to the same number. We can do that in a problem like this. We can take a look at these values here, look at my coordinates. I'm just going to choose two of them for the sake of looking at them. We have 460, and we have, just to choose another one here, 690. And we can divide them by taking our y value and dividing it by the x. And 60 divided by 4 is 15. And also 90 divided by 6 is also 15. And what we see is that we're going to have the same numbers between those, which means this should be a proportional relationship. Now in a graph, we don't need to necessarily do this. We don't need to necessarily divide every single coordinate that we have here. There's an easier way. There's two things to look for in a graph to know that it is proportional. First, it needs to be a straight line. Now technically in this case, I know you're looking at it saying, well, that's a ray, because it seems to end at the point 0, 0. However, that's fine. Okay, two things to look for. One, straight line. Number two, it needs to also go through the origin. The origin is 0, 0. And it could stop there like it does in this case. It could continue to go all the way through and have a little arrow there showing it will go towards the negatives. But in this case, because this is talking about a circus admitting people, it is impossible to have a negative amount of people show up to the zoo or the circus or wherever we are trying to go to. And the same thing, it's not like people are going to get paid to go to any of these places either. Okay. Now, specifically talking about unit rate right here, which is what this question is asking. The unit rate of anything is a number compared to 1. And that's always what you need to remember when you are looking at a unit rate problem. Now, we've actually already done this. When we took our coordinates, just point out this one right here once again, 690, we actually found out exactly what the unit rate was in this problem by taking our y value, dividing by the x value. We got an answer of 15. So the idea is to look for that number 15, of course, but x does not go to number 15. What we need to look for is specifically the number 1 here. 1 and 15. And we can actually see that right here. That coordinate right there represents the unit rate. So whenever I'm looking for unit rate, I want to think of this number as 1 comma whatever that constant would be in my problem. In this case, 1 comma 15 is what the coordinate for my unit rate is. So I don't need to technically divide. If I can find an x value of 1, I can find exactly what the unit rate is. One more problem to look at here, dealing with graphs and proportional relationships. And I try to choose one that had a lot of different stuff going on. In this problem right here, it says, does the graph represent a proportional relationship? And what we have here is a relationship between x, the amount of time in hours, and y, the distance traveled in miles by a probe before it reaches Mars. So of course, I could take all of these numbers and divide them and kind of waste my time here. I'm just going to once again say, look at, is this a straight line that goes through the origin? And yes, it definitely is. It is a straight line. Through, and in this case, I'm just going to put 0, 0 there. Okay, that is my origin. And this should be enough of an explanation to prove that yes, this is in fact a proportional relationship. It tells me that there's a constant with every single value in this problem that makes this true. Okay, I could divide, get my answers, but I don't need to yet in this problem right here. Second part of this problem, looking at this, determine the number of miles the probe travels in 5.5 hours, sorry. So we have some information in this problem that we need to look at here in order to solve this. The first thing I would want to find is the unit rate in this problem. See if I can figure out what that unit rate actually is. Now, in this problem here, there's as much as I want to look at the one here and say, oh, look at it's, I don't know what that is. It looks like it's more than 10,000, but I'm not exactly sure. I don't exactly know what that unit rate is. I'm going to want to divide one of these numbers here. I also don't want to say 5.5. That's about, maybe about here. Move on up. What is that? Like 68,000? 67,000? I want to be as exact as possible. And I'm just guessing with those right there. We don't want to guess. So I'm going to take these numbers, and just like we did before, I'm going to take these and divide 24,000 divided by 2. And this gives me 12,000, which is my unit rate in this problem. It was tough to see, but it was at the point 1, 12,000. And I can use this 12,000 now for my problem here, because this 12,000 means 12,000 y's, which is miles in this case, compared to my x's, hours. This probe is traveling 12,000 miles per hour, or 12,000 miles in 1 hour. So if I want to know how far it's going to travel in 5.5 hours, I'm going to take this 12,000. Remember, we said that was in 1 hour. So all we need to do is multiply times 5.5 hours. And this should give me my answer. 12,000 times 5.5 is 66,000. So my guess wasn't even close right there. 66,000 miles is my solution. Whoops. Sorry about that. 66,000 miles. And that's it. All we need to do to solve this problem.